nucleus.
Okay, so I'll start off with ones that students have a tendency to just kind of forget and skip.
Okay.
All right, where is the pedunculopontine nucleus? It's in the caudal midbrain.
What is it again?
Pedunculopontine nucleus. It's a nucleus that helps to connect the pons and the peduncles. That's why it's called pedunculopontine, because it's between the pons and it's in the midbrain.
I was going to say, this is a while back. Hold on.
This is the first lecture.
Yeah.
This is the first. 2 additional nuclei located in your brainstem that are not associated with the cranial nerve. With your midbrain, specifically. We'll go with the midbrain specifically. Not associated with the cranial nerve. So it can't be mesencephalic nucleus, and it can't be oculomotor nucleus, and it cannot be trochlear nucleus.
Red.
That has to do with cranial nerves.
And that would be down in the bottom of the medulla. Because that's cranial nerve 7, 9, and 10.
The life function nuclei.
Red nucleus.
She's cheating.
sure.
She's looking at her notes.
Hey, I said that one.
Yeah, see?
What's the red nucleus do?
Just
Beginning of the rubrospinal tract.
Beginning of the rubrospinal tract.
just regular midbrain, or do we have to know?
It's rostral. You should know it's rostral.
Yeah.
You look at a brainstem section, you can see it there.
Then we have.
Oh, yeah.
Well, because then
Those are nuclei.
But it makes. Oh, that's medulla.
Those are tracts. So another one that's up in your another nucleus.
There's 2 that make up
Give you a hint.
the
Sits
ventral
immediately.
respiratory.
That would be medullary. Immediately posterior to your cerebral peduncles. It's an important one. Substantia nigra.
Oh, that's the nucleus?
Mm-hmm.
Interesting. Substantia nigra is a nucleus.
Cerebral aqueduct is a space.
It's just, okay.
It's a channel.
Because then you have both. Because you have that and then.
And rostral?
You're missing a letter.
I think I am too.
Substantia.
Right here?
Yeah.
Rostral midbrain or just?
Rostral. We're going to talk a lot more about it with Parkinson's disease and basal ganglia in the next unit. Yeah, that first week you're going to get hit hard. So I'm going to try and get them done this weekend. So if anyone feeling okay with this stuff and you want to look ahead, you can. Because I'm warning you that 2.5 weeks is going to go real fast for the last unit. Just giving you a heads up.
Learn my cranial nerves.
Okay, so name 2 nuclei that you may not have thought of them as nuclei, but they're nuclei. In the tectum of the midbrain.
These aren't these are more
Those are tegmentum.
tegmentum. Way back.
Okay, I wasn't crazy.
You are not crazy. So
Okay.
Huh.
I was gonna say, I'm like, that's what I can. Yeah, I was gonna say, I'm thinking of the midbrain and the tectum, and that's the only thing I can think of when it comes to right there.
Mhm.
So.
And so, which one is auditory and which one is visual?
Visual superior and auditory.
Which one is the start of the tectospinal tract?
That's a guess.
It is superior. So the superior colliculus, the inferior colliculus sends auditory information up to the superior colliculus, and it uses that information combined with visual to help you localize to where you should move your head and eyes. You're hearing us typically, hopefully, the sound and what you want to see are going to be the same place. You know? There's that loud noise over there, and that's what I want to see. So I'm going to look at it that way. You drew that, by the way. You drew part of that tectospinal tract in the drawing where you didn't have a spot for it in the last lecture. And I drew a picture of the visual information coming in and how 10% of it goes down and goes to the superior colliculus, and then from there it's going to those nuclei. But going down to cranial nerve 11, that's the tectospinal tract. Why might damaging the left pons cause you to have right-sided ataxia? So what's in the pons that could be damaged with a pontine injury?
Pontine nuclei.
The pontine nuclei, and they send information to the contralateral cerebellum. So if I damage my left pontine nuclei, so they cannot send information from the cerebrum on what are we going to do to the right cerebral cerebellum. The right cerebral cerebellum cannot set up a plan, and that's going to affect your movement on the left or on the right side of your body. Yeah, I mean technically the path would be, if you're talking corticopontocerebellar, you're talking from the premotor cortex to the cerebellum.
But we can consider it.
I mean, we won't sit there and go, well, you've got the corticopontocerebellar pathway, and then that has the cerebellothalamocortical pathway, and then you have the lateral corticospinal pathway. So, I mean, and technically, yes, you have those different ones. And you could break them into separate tracts: corticopontine, pontocerebellar, cerebellar thalamic, thalamocortical, and then lateral corticospinal would be all the individual tracts. But be able to understand that back and forth. So I flipped it around from what that is. I had the pontine nuclei on the other side. I've had things where I've had people draw it out, and they've drawn it out like that, even though the question clearly had it the other way. But the bottom line is, if you have a injury to a single corticobulbar tract, you will have no symptoms. Except for those two areas, and that's only if the injury to that tract is at or above the level of that motor nucleus. So if I'm talking an injury in the medulla, and I'm looking at cranial nerve 5, I don't even have to think about it, because cranial nerve 5 is above the injury. It's unaffected. I have to think about what's at the medulla level. If my injury is in the pons, I have to think what's at that level of the pons, wherever the injury is, and then below that. Those are the ones that I have to think about. But if it's only on one side, I can go, I don't have to worry about it at all, except for hypoglossal, I got to remember. And am I high enough that I might impact facial and get the lower half of the face? But otherwise, that's, yeah. And we're not talking about the cranial nerves 3, 4, or 6. Their control is somewhat different. So just don't worry about that. They get control from different parts of the cortex, so it's probably, so they don't call them the cortical bulbar. Consider them part of the cortical bulbar, even though they're traveling together. They come from different areas of the cortex, not that same primary motor cortex region.